In this video, I'll focus on some more problems regarding the mathematical concept of direct and inverse proportions. So I'll focus on some hard category problems. In the previous video, we focused on mediums, and now in this video, I'll focus on some hard category problems. So let's jump straight into the video. In the previous video, we focused on the medium category problems. So in this video, we'll focus on some hard category problems of the topic direct and inverse proportion. So if I first read the problem, the first problem, it says y is directly proportional to the square of x. So a variable y is directly proportional to the square of x. So when x is 3, y is 36. So you have to find the value of y when x is 5. So it says y is directly proportional to the square of x. Okay. So when x is what? When x is 3, y is 36. So when x is 3, y is 36. So we have to find out what? When x is 5, y is what? Okay. So when x is 3, we can find out what? X is square is 9, and when x is 5, x square is 5 square, which is 25, right? So what is the increase of x square from 9 to 25? The increase is 16 based on 9, based on the base value. So the increase rate is 16 by 9. We can also multiply it by 100 to get the percentage, which is roughly 177%. So the rate is 16 by 9. This is the rate, okay, of increase. The increase rate of increase, because it's direct proportion of y from 36 to what? Okay. So the increase would be what? The base value of y. The y would be what? The base value plus the increase. So the increase is what? The rate is 16 by 9 multiplied by the base value. So this is the increase. So the increase is what? 9 4 is 36, 16 4 is 64. So this is the base value plus the increase. So 36 plus 64 is 100. So y will increase from 36 to 100. So this is how the direct increase of y will happen based on the value of x. I'll now focus on problem number 2. So in the problem 1, we encountered a direct proportion problem. In the problem number 2, we'll focus on inverse proportion problem. So let's read the problem. So what does the problem say? It says a variable h is inversely proportional to the square of r. So when r is 5, h is 3.4. So you have to find the value of h when r is 8. So a variable 8 is inversely proportional to the square of r. Okay. So h is proportional to 1 by r square. So when r is 5, so when r is 5, h is what? 3.4. h is 3.4. Okay. So if r is 8, then h is what? Okay. So if I look at this, I'll try to solve it in a different way using a constant. So h is proportional to 1 by r square. We can also write what? H equals to a constant k by r square. Okay. So from here we can write what? We can write k is what? H into r square. So if h is 3.4 and r is what? 5 square, which is 25. So what do we get? The value of k. The value of k is 3.4 into 25. So if I use the calculator and say 3.4 multiplied by 25, which is roughly 85. Okay, which is 85. So the value of k is 85. Okay. So when r is 8, we know that h is k by r square. Okay. Now we know the value of the constant, which is 85. So when r is 8, meaning 8 square, which is 64. H would be what? 85 divided by 64. So if I use the calculator again, 85 divided by 64 is what? 1.32 approximately. So the value of H would decrease into 1.3432 based on the inverse proportion. This is approximately 1.32. The value of H will come down from 3.4 to 1.32 based on the inverse proportion with the square of R. If I now focus on problem number 4 of the hard category, this is similar to 2 but it's a worded problem. So let's read the worded problem. So it says the intensity of the sound I watts per meter square received from a loudspeaker is inversely proportional to the square of the distance d meters from the loudspeaker. So when d is 2, I is 30. So you have to work out the value of I when d is 10. So it says, if I use my pen tool, it says the intensity I is inversely proportional to the square of distance. So it's I is proportional to 1 by d square, or we can also write it in this way. I is what? If I use a constant, then it will be I equals to k by d square. Okay, so it says if when d is 2, I is 30. So when d is 2, when the value of d is distance is 2, then I is intensity is 30 watts, okay, per meter square. So what is the value of I when d is what? D is 10. So when d is 10, what is the value of I? You have to figure out this, okay. So if I use this formula, and let's say when d is 10, I get what? K by when d is 2, I get what? D square is 4, so I is intensity is k by 4, and I is 30 basically. So this is 30. So 30 equals to k by 4, or k is what? 30 into 4, which is 120. Okay. So the value of k is 120. So what is the value of I when d is 10? So when d is 10, it should be I equals to k, which is 120, divided by d square, which is 10 square, or 100. So we can write what? When d is 10, we can write I is 6 by 5. Okay, inversely proportional. So it is, so I is 6 by 5, or 1 point something. Okay, so this is the intensity when the distance is 10, and distance is the square of distance is inversely proportional to the intensity. If I now focus on problem number 7, so let's read the problem. It's a very tricky problem. So what does the problem say? It says a company has to make a large number of boxes. So the company has 6 machines. All the machines work at the same rate. So when all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. So day 1 takes 3 days, day 2 takes 4 days, day 3 takes 5 days, and all other days take 6 days. So if I now try to focus on the problem, so what is the requirement? You have to work the total number of days taken to make all the boxes. Okay. So when 6 machines are working together, they take 9 days, a total of 9 days. So when day 1 there are 3 machines working, day 2 there are 4 machines, and day 3 there are 5 machines working. So when 6 machines are working, they take a total of 9 days. So what is the total amount of work? It takes 6 multiplied by 9, which is 54 machine days. Okay, so day 1 3 machines are working, so it's 1 day, which is day 1. So the total of work on the first day is what? 3 multiplied by 1, which is 3 machine days. Similarly, on day 2 4 machines are working, so the total amount of work done on day 2 is what? 4 multiplied by 1, which is 4. On day 3 5 machines are working for 1 day, so the total amount of work done here is what? 5 multiplied by 1, which is 5 machine days. And for the rest of the, let's say the rest of the days it takes is x days, x number of days. So all the 6 machines are working for x number of days. So the total work done for the rest of the days, which is x days, is what? Is 6 multiplied by x, which is 6x machine days. So the total amount of work is what? On day 1 3 machine days, on day 2 4 machine days, on day 5 machine days, and the rest of the days are what? 6x. So this is the total amount of work, which is what? 54 machine days. Okay, so this is 54 machine days. So if I calculate 3 plus 4 7 and 1 12 plus 6x is 54. So 6x is 42, 54 minus 12. So if I solve this equation, I get x equals to 7. So the remaining number of days is 7. So what is the total amount of days? Day 1, day 2, day 3 plus the remaining number of days. So which is a total of 10 days is required to do all the work. Hopefully by now you have a good idea about how you can solve mathematical problems regarding the concept of direct and inverse proportions. So in the next video I'll focus on another topic, so stay tuned for that.